Hello children. Previously we studied about artificial sources of light and natural sources of light. So now we are going to study about properties of light. Okay. So the properties of light are rectilinear propagation of light, reflection, speed, interaction of light with water, types of material according to permeability, formation of shadows, plane mirror and images and spectrum. We will learn about these in detail one by one in later classes. Okay. So now we are going to see the path of light. Have you ever seen the scene of light penetrating through the branches of trees in the forest? It's beautiful, isn't it? And secondly, when you open the windows early in the morning, you can see the light passing through the windows, especially in buildings and at homes. So this is what it looks like. So this is the sunlight entering through the hole of a cement grill building. Okay. And this is the path of a laser light. This is laser beam. And now we are going to perform an activity to prove to learn more about rectilinear propagation of light. Okay. So first you need 3 empty matchboxes, pin, candle, wooden blocks and empty matchboxes. So you first take the empty matchboxes and wooden blocks. So first you take the inner tray of the matchbox and punch holes in the same spot. That is, you take the 3 different matchboxes and punch the 3 different holes in the same spot. So we have to arrange the trays in such a way that the 3 holes are in the straight line, that is between the wooden blocks. Okay. So the 3 holes must be in a straight line. And at the far end, as you can see in the image, you have to place a candle that is lit. Okay. So now you should view the flame. You should be able to view the flame. And secondly, we have to arrange the trays in such a way that they are not at the same height. That means the holes should not be in a straight line. And now if we view the flame, it will not be visible to us. So what does this prove? Firstly, we kept the trays in such a way that the holes were in a straight line. We were able to see. And when the holes were not in the straight line, we were not able to see the flame. So this shows that light travels in straight line. Okay. And it cannot bend the path itself. So this property is called the rectilinear propagation of light. Okay. So this is one of the most important property of light. So this is the pinhole camera. Okay. So first one is the wooden camera and the second one is the cardboard that you can make at home. So this is the camera. So here is the butter paper and here is the pinhole. Okay. You can make it easily at home with the available materials. Okay. So we studied about rectilinear propagation of light. So that is, light travels in straight line and light cannot bend the path itself. To study about rectilinear propagation more, so to know about it in detail, this pinhole camera helps us. Okay. So what is a pinhole camera? A pinhole camera is a simple device that helps us to understand the rectilinear propagation of light. So rectilinear propagation of light is one of the most important properties of light, and it tells that light travels in straight line and light cannot bend the path in itself. Okay. Did you understand? So till now I hope you're clear with what I taught. So now, as you can see in the image, the object is x and y. That is, top of the object is x and bottom of the object is y. Okay. So now you can view the inverted image of the object, that is y dash and x dash. I'll tell you how it happened. A light ray from x. So O is the pinhole. You can see the translucent screen. O is the pinhole hole. Okay. So light ray travels from X through XO and strikes the screen X dash. You can view the image clearly for a better understanding. I repeat again, a light ray from X travels through XO and strikes X dash. And similarly, a light ray from Y passes through YO. O is the pinhole. O is referred to. Pinhole is referred to as O. A light ray from object Y travels along YO and strikes the screen Y dash. And thus we get this. Similarly, all the rays between X and Y, all the rays fall on the screen Y dash and X dash. And that's how we get the inverted image of XY, and the inverted image is referred to as Y dash X dash. Okay, so we use a simple paper here. So the image produced is temporary. So if you want a permanent picture, you can use photographic plate instead of simple paper. I repeat again, uh, ray light ray travels from X through XO and falls on the strikes at the screen X dash. Similarly, a light ray from Y travels through YO and strikes Y dash. And all the light rays between X and Y fall on the screen between Y dash and X dash, and that's how we get the inverted image of the object X and Y. Okay, so this is the pinhole camera that we can easily make at home. So this is the normal butter paper and this is the pinhole. Okay, so you can make at home. I'll give you a simple activity. Okay, so pinhole camera is I repeat again, pinhole camera is a device which can be used to understand more about rectilinear propagation of light. And rectilinear propagation of light is light travels in straight line, and light cannot bend the path itself. Okay, so you're going to perform an activity at home. Okay, so you take two rectangular pieces of thick paper and a carbon paper and a semi-transparent paper, that is normally you can call it as butter paper, and adhesive to stick glue gum. So as you can see in the image, you should make two rectangular tubes. You have to make two tubes. Okay, so you have to take the rectangular pieces of thick paper and you have to make two tubes out of it. One tube should be smaller in diameter, that is it should be small, and the other tube should be greater in diameter, that is it should be big, because we should be able to slide it into the other tube. That is, we have to keep the small tube into the big tube without leaving any gap. So that's why there is a difference in the diameter. So you have to fix the carbon paper. In requirements, I told you to take a carbon paper, and you have to fix that in the big tube that which has the greater diameter. So you have to make a hole at the center of the carbon paper. Okay, so you have to close one end of the second tube, that is the tube which has greater diameter, with butter paper. Okay, and you have to slide the smaller tube into the bigger tube in such a way that the butter paper is inside. Okay, can you understand? So the first tube you fixed carbon paper, and in the second tube you fixed the butter paper. So now we are going to keep the smaller tube into the big tube, so that butter paper is inside and carbon paper is outside. Okay, butter paper should be inside and carbon paper should be outside. Okay, so you have to light the candle, and as you can see the second part of the image clearly, carbon paper should be towards the candle. So If we go closer to the candle and view with the tube, we will be able to see a smaller and a brighter image. Okay, so we can also change the size by adjusting the tube. Remember the point, butter paper should be inside and carbon paper should be outside, that is it should be towards the candle. And as we go closer to the candle, we will see a smaller but brighter image. Okay, we can also change the image size by adjusting the tubes. Okay, so by this we can view various images. So the images can be straight, inverted. We have to observe whether it is straight, inverted, bright or sharp. Okay, we can also be able to see things like sunlight, and we will get a good image out of it. So we have to do this and bring it in the next class. Okay, so you have to remember the point that butter paper should be inside and carbon paper should be outside. So I'm going to tell you an interesting fact now. So before the advancement of camera, that is before the camera was developed, pinhole camera was used to photograph the movement of the sun. Pinhole camera was used to view the sun for a long period of time. So this type of photography is known as solography. Okay, so that type of photography is known as solography. So it was used for observing and recording solar eclipses. Okay, and it was also used to take photograph of stationary objects. And I'll tell you about a scientist. You should definitely know him. His name was Al Hassan Haytham. He was a scientific thinker he made an important contribution to the understanding of vision, optics, and light. That is, he keenly observed that light coming through a tiny hole traveled in straight line and projected an image onto the opposite wall. Okay, so he observed that light coming through a tiny hole traveled in straight line and projected an image onto the opposite wall. So based on such experiment, he concluded that vision is accomplished by rays coming from. So based on that experimentation, he concluded that the vision comes from rays, that is accomplished by rays coming from external sources. Vision comes from external sources and enters the eye rather than rays emitted from the eye. So what was commonly believed was rays rays were emitted by the eye, but that was not true. So the vision is accomplished by rays coming from external luminous sources. Okay, and entering the eye rather than through rays emitted from the eye as well as through as rather than through rays emitted from the eye. So he is the first person to experiment with light and found important properties like the rectilinear propagation of light. So his name was Al-Hasan Haytham. Okay, so he contributed to the rectilinear propagation of light. So today we studied about properties of light, pinhole camera, and we performed two activities. Okay, and I demonstrated you a model. Okay, so the homework is you have to make a pinhole camera following the instruction given in the textbook, and you have to bring it in the next class. Thank you, student. I hope you understand what I taught today. Thank you, students.